mostly when we are talking about first difference, second difference, right? So rate of change relates to this thing. Okay? What do you guys know what it means? What does it represent? What does rate of change represent? How much it increases or decreases by. That's right. If you guys remember with linear, we dealt with slope. I don't know if you remember this from grade 9 and 10, right? Slope is part of your linear rate of change, right? You see how much is it going up by, or how much is it going down by, the slope, okay? That's your rate of change. So it's how quickly your point or your graph is changing. Okay, so I'm not gonna be writing rate of change every single time. I'll be writing ROC or ROC. Okay, so to calculate the ROC, which is the rate of change, which is the how quickly so the rate of how quickly at which something is changing. Remember how we used to calculate the slope of a line given 2 points? Rise over run. Yeah, rise over run, which is delta y over delta x, right? Which is the difference in y versus the difference in x. Okay? So the slope, which is the ROC is often indicated by the slope of a graph, right? And the slope of a graph is usually, we find it using delta y over delta x, or the difference in y over the difference in x, or rise over run. You've probably heard one of these at least. So when you are finding the slope of a line or the rate of change of a line, you need 2 points. Okay? And in the 2 points, you're going to have x and y, x and y. So what we do, we call them x1, y1, and x2, y2. Right? So let's say I determine that this is my first point. It doesn't matter which one is your first point. You're going to end up with the same answer. Okay? So let's say this point on the line, it's clear point. I know what it is, right? Then I'm going to label it as x1, y1. So let's say this point is whatever, 2, let's say it's 4, 5. Okay? This is 4, this is 5. I'm not going to use values for this one. I'll use values down there. Okay? So that means your x is 4, your y is 5. Okay, a point is made of x and y, right? In this case, your x and y are 4 and 5. For example. So the important part is that for this point, you're going to label it as x1, y1. And the second point, we're going to label it as x2, y2. Okay? So here's what we have to do. So I have x1, y1. And I have x2, y2. Here's what we have to do. To find the average rate of change, I have to do y2 minus y1 over x2 minus x1. Okay? So that's the difference in the y divided by the difference in the x. Okay? If I'm looking at the difference in the y, that's the difference in the y. So that's my rise. Okay? And if I'm looking at the difference in the x, that's the difference in the x, and that's the run. And that's why it is rise over run. Okay? So the formula that you want to remember is the y2 minus y1 over x2 minus x1. No matter how the graph looks like, you can find the rate of change between 2 points. As long as you have 2 points, you can do that. Okay? So even if I have a graph that looks like this, right, I can take 2 points. Now that won't be the rate of change for the whole graph. It will be the rate of change for that section of the graph. I can take 2 points, and I can find the slope of the line that joins these 2 points, and that would give me the average rate of change. Okay? But that would be only for this section of the graph. Okay? We won't be doing that as often, we're going to be doing only the rate of change for the linear, and then for the quadratic, we're going to do second difference, first difference, and we'll talk about it. Are we okay with this formula? So let's look at example, because with examples, everything would be clear. So calculate the average rate of change, okay? Average rate of change between each pair of points. Explain what that rate of change means. Okay? What I did here is I added the letter A because that says average and it becomes A rock. Okay? Average rate of change. So I have the altitude of an airplane. I have time and I have the airplane height. Which one represents X? Time or height? Time represents your X, right? So this is your X, this is the Y. Now which one would you say is X1? Now you have to label it, right? So you can pick one, and then this is going to be, let's say, X1, and this is going to be Y. X2, Y2. To find the average rate of change, or the slope or the rate of change, you are going to do the formula, use the formula, y2 minus y1 over x2 minus x1. So that tells me that your y2 is 1400 minus 2000. Anyone have problems with this? So I labeled my points, I looked at where y2 is, and I plugged in that y2. I found where y1 is, and I subtract that from y2. Divided by, you have the x2 minus x1. So 4 minus 0. So that's going to give me negative 600 divided by 4, which is going to be negative 150. Are we okay with this? Are we okay with this? Okay. Now the only thing that the slope is different than the AROC or the rate of change is that the rate of change has to have a unit. The slope doesn't have a unit. Okay? So because I'm looking for the rate of change, I have to include units. So remember that negative 150 is because I divided the difference in y by the difference in x. What would you say? Meters per minute. That's right. Because the unit for y is meters, the unit for x is minute, so what I will have is meters per minute. Right? Because if you look at the y, the unit for y is meters, and I have y on the top. If you look at the x, the unit for the x is minute. So I have x at the bottom, so it becomes meters per minute. Now, can you describe this rate of change for me? So the altitude of the airplane is negative 150, or not the altitude. The rate of change of the airplane is negative 150 meter per minute. That's right. It's decreasing, it's descending by 150 meter per minute. Right? So the airplane is going down 150 meter every minute. That's what it means. Now, how do I know that it's going down?
Because the negative.
Because it's a negative. But the rate of change is decreasing. It's negative. Okay? So if I want to describe this, I'm going to say that the height of the plane is decreasing by 150 meters per minute. Are we okay with this? money, rental cost. Okay? Now I need to find the average rate of change for the vehicle rental cost. They give me 2 points. Okay? First thing you're going to do, you're going to label the 2 points. X1, Y1, X2, Y2. So in this case, they're labeled, this is X1, Y1, and this is X2, Y2. Does it matter if I call this X2, Y2 and the other one X1, Y1? Does it matter? It's not going to matter. It's going to give you the same answer. Okay? Doesn't matter which one you label. All right. To find the average rate of change, I have to use the formula. And then plug in my numbers. 700 minus 400 divided by 400 minus 200. So that's going to be 300 over 200, which is 3 over 2, or 1.5. Now remember, this is the rate of change. What do we need to include with that? The units. So it's $1 per kilometer. Remember, the unit for the Y is dollar, and the unit for the X is kilometer, right? So it's going to cost you $1.50 per kilometer. That's what it means. Okay? That means you're going to have to pay $1.50 for every kilometer you drive. Does that make sense to you guys? What's under the 2? 2. 3 over 2. When you reduce 300 over 200, that would be 3 over 2. Are we okay with this? Required to stop a car depends on the speed at which the car is traveling. Use the tables below showing the reaction distance and braking distance needed to stop a car on dry pavement for a given speed to answer the following. So calculate the average rate of change between consecutive points in each table and describe the rate of change revealed in each table. So the question is asking you to find the average rate of change between consecutive points. What does the word consecutive mean? One after the other. Okay? So that means I have to find the average rate of change. I'm going to start with the first 2 points. I'm going to find the average rate of change. So I'm going to take the second 2 points, do the average rate of change, and then I'm going to have to describe that average rate of change. Okay? So if I'm looking at the first 2 points, the average, this is my Y value, right? So this is Y1, and this is X1, and this is Y2, X2, right? So to find the average rate of change, you're going to have to do the Y2 minus Y1 and divide it by X2 minus X1. Are we okay with that? So 2 minus 0 divided by 10 minus 0. So that's going to be 2 over 10, which is 0.2. Okay? Now, look what's going to happen. Eyes on me for a second. Now, to do the next 2 points, I'm going to have to take these 2 points, right? So So now this is your y2, this is your y1, this is your x2, this is your x1, right? So these are the next two consecutive points. So it's going to be 4 take away 2 over 20 take away 10. Again, I have 2 over 10, which is 0.2. So you're going to think about it like, if you guys remember the first difference and second difference. So you're going to do this minus this, and then divided by this minus this. And you're going to do this minus this, right? What would be my next one? 6 minus 4, okay? 6 minus 4 over 30 minus 20, which is the same thing. 2 over 10, which is 0.2. Okay, so that was my next one. What will be the next one? 8 minus 6 over 40 minus 30, and that's going to be 2 over 10, which is 0.2. And then the last one is going to be 10 minus 8 over 50 minus 40, again 2 over 10, which is 0.2. So, what can you tell me about that AROC, or that average rate of change? Constant, right? It's a constant average rate of change. So if you get a constant average rate of change, what does that mean? What kind of function is this? It's a linear function because you have a constant change. Okay? It's similar to having the first difference constant. Same idea. Okay? So for this one, I'm going to say that the, let me just write, so it's a constant rate of change, so the reaction distance increases by 0.2 meter for every 10 kilometer per hour increase. Increases by 2. So we have an average rate of change is constant. Right? And then since it's constant, I can say that the reaction distance increases by 2 meter for every 10 kilometer increase in speed. Right? So that means if you are driving, let's say 30 kilometers per hour, right, you would need a certain distance to stop. But if you are driving 40 kilometers per hour, you need 2 more meters to stop. Where did I get that? The reaction distance increases by 2 meters for every 10 kilometer increase in speed. Where did I get that?
Because we have double 2 versus 8 10.
Well, I got it from here, right? You see this?
Okay.
Right? It's a 2 meter for every 10 kilometers per hour. 2 meter for every 10 kilometers per hour. Okay? I'm missing an hour. Okay? So what I want you to do is I want you to find the answers for the table below and make a statement. Is it constant? And if it's constant, tell me what is it going up by. If it's different, then just